Welcome to the another session on basic maths. So today, what are we going to learn? See, there is something called binomial expansion or binomial theorem. Okay, this is what binomial theorem. So, what does it involve in binomial theorem? There are something called NCR. So this is known as the binomial coefficient. What is this known as? Binomial coefficient. Okay. So this particular NCR example is 2C0, 2C1, and 2C2. Like that, it goes continue or it actually this is n is 2, r ranges from 0, 1 and 2. This can also be written as C0, C1, C2. If I write only these three, or I can say like this, based upon the value of the n. So such particular binomial coefficients find applications in various expansions. We'll again try to see in another video what are those expansions and how do we use this particular NCR. Basic Mathematics 4. Okay. We are looking at binomial theorem or binomial coefficients, what we say. See, when do we call this as a binomial theorem? When we say x plus a power n, if you are trying to expand this term, what result we say generally is known as binomial theorem. What is this particular expansion? Let us understand a little bit more in this. Suppose if I tell you there is one term x plus, a. Okay. So this, how many terms are there in this? There are term 1 is x and term 2 is a. So this is known as binomial. But what is the total power of this particular expansion? X plus a power is 1. So what is the answer? I write it as 1C0 into x plus 1C1 into a. This is otherwise also known as 1 into x plus 1 into a. Okay. So this is the number one expansion, what we are trying to understand. But just imagine the power x plus a power, if it is 2. Okay. How do we do this? We generally do this as a polynomial multiplication x plus a into x plus a. Then it is okay. We can continue the multiplication and do. But if these keep on increasing, x plus a power 3, x plus a power 4, x plus a power 5, then we are in trouble. So that is the reason binomial coefficients are introduced. Then if I just mention around three terms. Now, let me explain or x plus a power 2. I think everybody knows what is x plus a power 2. This is x square plus 2xa plus a square, right? This I can write it as 1 into x square plus 2 into xa plus 1 into a square. I think you agree. This is also written as 2C0 x squared, 2C1 x into a, 2C2 a square. Till now you try to understand and then please practice what I have shown you. Then again we'll come back with another video. Basic maths, fine. Okay. So we are looking at binomial theorem, binomial coefficients. So if I write simply x plus a power 1, it indicates this is, the power is 1. So there will be two terms. You can say this, this is power is 1, terms are 2. If I write x plus a power 2, then how many terms you will have? X square plus 2 into a into x plus a square. You can now look at this. There is a term. This power is 2, but the number of terms are 3. You can say, look at this. Number of terms are how many? 3. So the power and the number of terms, those are very important to understand. Now you write x plus a power 3. So how many terms if I expand this? X cube plus as we write, x cube plus a cube plus 3x square a plus 3ax square. How many terms are there? You can look at this. The power is 3. The number of terms are 4. But generally, to remember, we write like this. But generally, the term x a cube is not written immediately after x cube. We need to write this after writing the final term. So x cube plus 3x square a plus 3x square plus a cube. So this is again one more understanding in the basic mathematics. Basic math session 6. So what is that we are trying to do? If I write x plus a whole square, if I expand, what do I get? X square plus 2xa plus a square. It is right? A square plus 2ab plus b square. This can be written as 1 into x square plus 2 into xa plus 1 into a square. Still more, it can be written as 2c0 x square plus 2c1 x into a plus 2c2 a square. See, for now, just try to understand the flow. Okay. Now, what is the next one? What we write? See, I write it in a more elaborative way. X plus a whole square is equal to the first term. What do I write? 2c0 x power 2 minus 0 to a power 0. That means I try to write each term in terms of the x and a. Second term is 2c1 x power 2 minus 1 into a power 1. See, you should understand in the powers and exponents, a power 0 is how much? 1. And 2c2 x power 2 minus 2 a square. In the last term, you get x power 0. First term, you get a power 0. Okay. Now, little more in this. What is term 1? 2c0 into x power 2 minus 0 into a square. What is x power 2 minus 0? X square only. What is a power 0? 1. So that means first term is left out with 2c0 into x square only. Term 2, I can write it as 2c1, x power 2 minus 1, a power 1. Similarly, term 3. But you should understand the order of increasing 2c0, 2c1, 2c2, where 2 remains constant because the power of the binomial term, binomial expansion, x plus a, power is 2. So ultimately, we can write the general term as TR plus 1 is equal to NCR, x power n minus r, a power r. That means how many terms we will have? 3 terms. So T1, T2, T3. Okay, right. Basic math 7. And let us look at what does this say. See, 1 plus x power n is yet again a binomial expansion wherein we have replaced a with 1. So 1 plus x. So 1 plus x power n is what? 1 plus nx plus n into n minus 1 by 2 factorial x power 2 plus so on. But for the conditions where the mod absolute value of x is very much less than 1, higher powers can be neglected. Let us look at an example. Suppose now when the higher powers are excluded, so what is happening here? 1 plus x power n becomes 1 plus nx only. So let us take an example of the square root of 1.01. If I want to find square root of 0, square root of 4, it is 2, square root of 9, 3. But what is square root of 1.01? So it can be written as 1.01 power half. It is 1 plus 0.01 power half. Now x is nothing but 0.01. But whereas 0.01 is very much less than 1. So straight away the answer would be x equals 0.01. So answer is 1 plus nx. What is n here? Half. So 1 plus half into 0.01, that becomes 1.005. Okay, so this particular operation or this particular fundamental is also very essential in many instances. Bye.